kind of dumb shit is this?
Okay, we'll buy that camera.
Where the hell is this camera?
The point is,
Where is the camera? Where do you even see it? I don't even see the damn thing. This? Oh, this. Oh, this is a microphone. Okay. Oop. This is very exciting. So the camera wasn't hooked up correctly. Okay. All right, sorry, I forgot one of my cords, so I can't connect to this thing. But we gonna find another way to do it. Gotta be the right class. Muy extraño.
Recording in progress.
You have no idea how much this dumb trick that I'm doing right now has helped me.
Right over here. Cause like, I don't want this.
Because I don't know if anybody's ever had to do anything like this before, but like, you know, like you want to, let's say, project something to a screen somewhere, wherever it is, okay? So I mean, I'm not joking about what I'm about to say, that people made an $8 million theater. $8 million. But there's no real place to hook up a computer for a projector. Okay? So they wheel out this stupid little projector in the middle of the thing. I mean, I'm talking about a nice theater. They put this little projector behind a few of the seats, and then they sit there and they shine at the stage, and that's how they're doing this thing. Well, it wasn't working because the problem is that the guy who I had doing this presentation, he needed to use the computer at the podium. And they had this computer set up at the projector somewhere in the back in the audience somewhere. Well, everyone was like, all right, forget it. We're just not gonna do the presentation. We just, you know, he'll just talk. I was like, nah, we can't do that. It's gonna be bad. How about we do it on Zoom? And they're like, what are you talking about? And I was like, well, I do Zoom all the time for class. We always project to the screen pretty easily, right? I'm like, all you have to do is just join Zoom on one computer, join Zoom on the other computer, and push share screen. You can share whatever you want, anywhere, without anything, no equipment, no nothing. You know what I mean? But anyway, surprisingly, this has saved my tuchus a few times. What is this? So. All right. So I guess we finished up D.
2 and B3.
There. But we actually did a bunch of this already. All right, let's finish this stuff. So let's go to my old notes. Which I'm deleting. Very intelligent. All right, hopefully I put some notes here. Oh, good boy. All right, so let's discuss permutations first. All right, so permutations is when the order matters in something. So all permutation, so the word permute means like to switch or rearrange something. Okay. So permutations is an arrangement or like a switching or something like that. So for instance, if I said like, oh, we're all sitting in these chairs here, what if we, swap seats with each other? How many different ways would there be that we could do so? Does that make sense? But then obviously like the order in which the two people sit in the chairs like matters. If the first person sits there, second person sits there, or if the first person sits there, second person sits there, like it makes a difference. It's a different order, right? Does that make sense? If I say these two people, this group of two people attended the class, and then I'm like, her and him attended the class, or I start saying this group of two people attended the class, and I say he and she attended the class, like that doesn't really make any difference. The order is not really meaningful. Does that make sense? You understand what I'm saying? So we're constantly having to decide in these questions, whether or not the order makes a difference or it doesn't, right? So permutations is when the order does make a difference, right? If you have an arrangement, it matters which way you decide to arrange the things. That would be, well, if I switch two people, it'd be different or a different arrangement. Is that correct? As opposed to switching the people inside the group. Changing the order of the people inside the group doesn't make any difference. Is that right? All right, so repetitions are not allowed. To permute just means to rearrange or to arrange. A permutation is an arrangement. NPR, we say, is the number of permutations of n items taken r at a time. So given 6 letters, how many 3-letter words can be constructed using each letter only once? What would you say? How would we do this? I feel like we did this before.
We can go like Mississippi.
Well, that we didn't, but that we were using all the letters, right? Now they're just saying, don't use all the letters. How many choices do you have? And we're assuming in this case that these things that we're permuting are distinguishable from each other, or in other words, they are not the same thing. Okay.
How you doing, sir?
What's up? How you doing?
Hello, fine. I just want to know that I got the right book, right? This the right book?
Nope. That's the algebra one. Wrong one. The foundation of mathematical units. I'll show you afterwards. Well, let's. Man, I don't even remember what the damn book is called. The old one was mathematical ideas. I'll look it up right now. I'll look it up right now. It's on the syllabus. It says it on the syllabus, but. If you, what I'm gonna show you though is that you don't really have to go and get the book. Cause it's all online for you.
Yeah, it's very for me personally because all that.
It's
I
easier.
need a physical.
No, it's easier with the book,
Yeah.
but I'm just saying like. Until you can get the other one.
Yeah. Well, how much is it?
You can rent it from there, you don't need to buy it. Just take it from the math lab.
I'm gonna go to the map out at the Pine City.
Yeah, just go to the academic assessor, that's where that came from. That's from the academic.
You know what I'm saying?
Mathematical ideas, yeah, it's called mathematical ideas.
Okay.
Mathematical ideas, Miller, Hornsby, Perrine, and yeah, that's it. Miller, Hornsby, Perrine. So it's called mathematical ideas, but if you just tell them the name of your class, you just ask them for the book, they'll give it to you. It's MGF 1106,
Mathematical.
ideas. 2 words.
Ideas.
All right, so given 6 letters, how many 3-letter words can be constructed using each letter only once? What would you say? 120 is correct. How do you get that?
Well, the first one is around the 6. We both, we can only read them, then this one I 5, and then this one.
Perfect. Very good. So the thing is though that I didn't even teach you anything on how to do this. We've already done it. Is that right? So there's 3 slots in this case is correct. We have n total distinguishable items. We're gonna select, we say are many of them. Does that make sense? So in this case, what's R? Three, we're selecting 3, right? Because we have 6 total, right? R is the thing we're picking out of those 6. So N in this case is 6, okay? Okay, I guess we're done with this. All right, so there's R many things you're gonna pick. There's N minus R then you're not picking. Does that make sense? You have 6 choices for the first one, then 5, then 4, or 120 choices. We can also write this out using factorial notation. All right, so that's how they write the formula. So I don't really 100% suggest to use the formula with something like this, because if you don't understand the 6, 5, 4 thing, you're not going to be able to do most of the questions anyway. And this is just one formula. Does that make sense? All right, but this formula does help us with the next formula. So we're going to go over it. So 6p3 can be thought of as 6 factorial over 6 minus 3 factorial, or 6 factorial over 3 factorial. Why can be thought of as 6 factorial over 3 factorial? Because 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is just 3 times 2 times 1. So these cancel here. Does that make sense? And you get the same thing. Is that right? Also, another way to say this is that if you did 6 times 5 times 4 times 3 times 2 times 1, that would be really arranging all 6 things. But we're not doing that. We're only arranging 3 of them. Okay? So and it's important to think about what I'm saying here, because it explains why the next formula works. Right? So if we have 6 times 5 times 4 times 3 times 2 times 1, and then it says to divide this by 3 times 2 times 1, or this is the same thing as 6 factorial over 3 factorial. We're dividing out the 3 factorial. Because you can no longer order or arrange, whatever, the last 3 items after selecting 3. So you would have previously been able to arrange the 3 items that you that are like missing, the 3 slots that are missing here, right? So we can no longer do that, so we divide those out. Does that make sense what I'm saying? You know what I mean by that? All right, again, the main thing here is that there's going to be 2 formulas, NCR and NPR. P is for permutation. In this case, the order actually matters, all right? You will also see, like everybody always says, you know, you put the lock on the locker or whatever, and they call that a combination lock. It really should be called a permutation lock. Because it's not looking for combinations. Combinations we'll see have to do with groups. The order within the group doesn't make any difference. If you put the wrong, if your code for your locker is 1, 2, 3, and you put 3, 2, 1 in, is it gonna open?
No,
No, you have to do it exactly. Is that correct?
right.
Right? The order matters. Is that right? The people always use this word combination in English all the time, but actually they're not using it right. Or there's a way in, let's say, you know, like our regular vernacular or the regular way we speak. Sometimes we dumb down what the word means just to use it. Is that right? And then it becomes common or everybody just uses it that way. Does that make sense? All right, you're gonna see there's a slightly different actually definition for permutation than what they said. Or excuse me, combination than what everybody usually says. All right, so what would 5P2, first of all, what does it mean? And then how are you gonna calculate it? What does 5P2 mean? So what's N, what's R, and then what does it mean? 5P2 is the number of ways, what? Number of ways you can do what?
I'm lost, I'm really lost.
We want to hear that. What did we just say? Come on.
So like, the number of ways you can arrange 5 things without being placed.
Nope. It's not what we said at all. Yeah, well, you came up with some parts that actually are gonna be close. But then one part you just went, "Ooh," that was all right, there's definitely 5 total things, right? So in this case, we'll say, again, I'm just gonna write the formula here again. NPR is equal to N factorial over N minus R factorial. Okay, so obviously in this first case, N is 5 and R is 2. Is that right? So what does that mean? That's correct, but I want to know what this means first, because it doesn't really matter if you know how to calculate it, if you don't know what it means, you're not gonna be able to apply it and answer your question. Does that make sense? So what does 5P2 mean?
If I know that M is 5 and R is 2, I don't see an N or R.
Well, this one is the N and that one's the R. But-
Oh,
But they just like this, like N R, okay?
okay.
But what does it mean? What did we just say it means?
It's like, I have 5 things in a basket and I take 2 of them out and I don't put it back.
Very close. Very, very, very close, okay? You have 5 things. You want to take 2 of them out, but you want to ask how many ways you can do that. How many ways can you take the 2 things out? Given that you have 5 different things to select from. Does that make sense? You understand, guys? Does it make sense? Right? You can't pick 6 from 5, right? That's why R is always less than or equal to N. Does that make sense? You understand? Now, I think that if you just think of that, and you remember what we did last time, because honestly, we did a lot of these questions last time. I think it's actually extremely easy to say. Like, really easy, honestly. This part, okay? Is easy to say that there would be 5 choices for the first one and then 4 choices for the second one. So you get 20. Does that make sense? I don't think you need a formula. I don't think you need anything. You understand what I'm saying? Does that make sense, guys? I'm going to use the formula again. Really, I don't suggest you use it to do these questions. I suggest you use it to understand the next formula, okay? But 5 times 4, so then how does that work? Well, if we did 5P2, this is the same thing as 5 factorial over 5 minus 2, 3 factorial. Is that right? Right. And then this is 5 times 4 times 3, 2, 1, or I'll just write 3 factorial. We divide that by 3 factorial, so then we get the same 20 we got before. Does that make sense? Do you understand, guys? can you please tell me then what 10p3 means first? 10p3 is the number of ways, what? And I need you to use the words that we keep using in these things. We haven't gotten to the next one yet, but arrangements and groups, okay? So 10p3 is the number of what? Arrangements or groups first? Arrangements. Permutation, we haven't talked about groups yet. Permutation is always arrangements. Does that make sense? Because the order matters. You understand? So arrangements of what? Let's say arrangements. Don't mix up these two words, groups and arrangements, because that's like mixing up and and or, all right, from before, all right? So like this, this is the number of arrangements of what? Somebody tell me.
Anything?
So we're gonna pick 10?
I'll pick 3.
I even feel like the P means pick. Does that make sense? Serious, all right? So then you're picking 3 and arranging them. What? Tell me, what does this mean? Sorry? We're trying to say how many ways, but we didn't say how many ways of what? What's the of what? There's 4 choices in the second one. You have 5 distinct things to select from. You pick one for the first one. There's only 4 remaining. For the next one. Say it one more time. But let's say arrange. How many ways can you arrange 3 things out of the 10? Does that make sense? All right. But again, this is now the 4th time we're saying this. I still haven't really heard people sit here and be able to read it. I'm not even talking about how to do the math. I'm not even talking about how to apply it. I'm just asking you to know what I'm writing. Does that make sense?
Yeah.
All right. So this is what? The number of ways to arrange 3 things or line up 3 people out of 10. Does that make sense? You got me?
Yes.
All right. How am I gonna calculate it now? Okay, with the slots first. How many slots? 3. You're selecting or picking 3 things here. So it's 3 slots. Is that correct? What do I write in each one? 10, 9, 8. So we get 720. Is that right? But you're right. You could do it the other way also. It doesn't really make any difference. But I think if you keep using the formula, you have no idea what this actually means. And you will get the questions wrong because you won't know which one to pick. Does that make sense? So then these cancel here, so you get the same, whatever this is. And obviously, if the formula was going to give me a different answer, it wouldn't really be such a great formula, right? The formula is doing the same thing. I'm just explaining what the formula means. Does that make sense? Question? How many ways can I arrange 20 things taken 6 at a time? How do we calculate this one? Now again, let's not even bother with formulas and all this stuff. Can we do this with the slots? If so, how many slots would there be? 6. There's 6 different things that can happen. Is that right? How many choices did you have for the first one?
20,
20. Then what?
19.
18, 17, 16,
Does that make sense?
Yes.
This is the same thing as saying 20p6, which is the same thing as 20 factorial over 14 factorial. Question? I do not, I'm gonna say this, and I'm sorry, but like, there is no way anyone could ever convince me that this is hard. you understand what I'm saying? But you gotta make it easier in your head. Alright? Cause I'll say that, and then I'll do some of these questions sometimes, and I won't be able to get the answer. Or I'll read it wrong, or I'll start thinking about it wrong, and I'll multiply by 2, and I shouldn't multiply by 2, or something like that. Does that make sense? These are easy things to make mistakes on, but if you understand the formula very well, and then you understand how to just separate the things, there's really only gonna be 2 formulas. Alright? Yeah,
So you just take like 6 and then you go down to 20 and then multiply.
I mean, you don't understand why, but in this case, yes. Question?
Why?
Because you have 20 choices for the first one, then 19 choices after you selected something, then 18 choices after you selected 2 things, then 17 choices after you selected 3 things.
Okay.
You have 20 people and I want to line up 6 of them, then I got 20 different people to choose from for the first person in line, right? I only have 19 people in the second person in line. Is that right? I can't be the same person twice. Contractor builds home of 12 models and presently has 4 lots to build on. In how many different ways can you arrange homes on these 4 lots, assuming 4 different models will be built? This is kind of, should be pretty easy at this point, I think. What would you say?
Well,
12 P4 is correct. So that'd be what, 12 factorial over 8 factorial, or again, you just draw 4 slots, 12 times 11 times 10 times 9. And I'm gonna say this over and over and over again. This, a person tells me, I know they understand. This, a person tells me, I'm honestly not sure. If they actually understand. You understand? Question? So what is this, 120 times 99, so that's 1200 minus 120, yeah, 1080 or whatever, 1180.
8.
Oh. I don't know how to multiply.
Yeah, minus.
So this
or
is
multiply?
20 times, sorry, 100 minus 1,
Oh,
it should be 12,000 minus 120, so we end up getting 11,000, whatever I just said, yeah. Question?
That's what I got. Yep. That's what I got.
Okay, so now is the other formula now. Now this one's not as simple. Right? It's very closely related though. The combinations means order does not matter. This is really the number of groups now. So NCR, now we said it before, most of you guys weren't actually writing it down. But even if some of the people that were writing it down, I think didn't really remember anyway. But now I think you will remember. So NCR is the number of groups taken R at a time from indistinguishable items. The only difference here from the last time was I wrote groups. Previously I was writing arrangements.
It is recorded right now.
Mhm.
Okay.
But this has to do with groups as opposed to arrangements. Now, I really should ask this first before we go into this whole thing, but if I said you need to pick 6 people from the room and line them up, or I said you pick 6 people from the group and make a group out of them, are there more ways to make the groups or are there more ways to line them up? And then why? Why?
Does it matter like order? Like order of like,
So that means there will be more ways?
I don't know, it just depends. I need to hear more information.
I would say
Say no to what?
there's no one way of lining them, not in that group.
There's,
There is.
is what? More ways?
Often, same amount that is in the line, that's the same amount. you
Same
do.
amount of ways to line people up, the same amount of ways to group them?
That's what I'm saying.
Is that what everybody else says?
Like, you mean like order in the line makes a difference? It's like order?
I don't know, it's a line, you tell me.
Sure, right?
When you get in line somewhere, hey, let's go to the game. I'll stand in front of the line, you stand in the back.
Yeah.
Does it make a difference?
Yeah.
It makes a difference, right?
Yeah,
So like no, but like, I'm being silly with this, but everybody always asks this question, but you need to reason that out yourself in terms of the actual question, because they're not gonna sit there and tell you. Does that make sense? So like, you gotta know that, right? If I say line people up. If he goes first and you go second, or if you go first and he goes second. Are they the same line? No, right? What if it's the first person in the line wins the lottery?
Yeah, it's only.
Second person don't win. Like, it makes a difference who goes first, is that right?
Alright.
So but you get me with this thing? You understand what I mean by order? So. I still haven't heard really an answer that's definitive. Do you think? If there's 20 people and I start making groups of 6. Or if there's 20 people and I start lining up 6 people. Are there more, less, or the same ways to do those 2 things? And then why or why not?
Based on
There-
what you explained just now, I'm looking at, you have more ways of lining them up than a grouping.
Why?
Because as you said, we can make the line 3 of us, and I'm first, you second, he's third, then he's first, second, third, first, second, third. So that's different ways of
Three ways.
one line. But if you say a group of 3 is also 3 of us, that's one group. That's all I see.
That's perfectly correct. All right, so the thing is that. We can always pick a group of people, is that correct? But then if I was to line those people up. Or items, whatever, it doesn't have to be people. If we were to line those people up, there'd be a bunch of ways to line them up. Is that right? Right? So. There has to be more ways to line the people up. Right? Isn't this one group of students in this classroom? Right? How many ways would there be to line you up? I mean, a lot. Is that correct? Right? Okay, so the idea is that. So there's n things, we're gonna pick r of them. That means we don't pick the n minus r. Does that make sense? So the previous formula just said that when we do npr, this is equal to n factorial over n minus r factorial. We're dividing out the number of ways that we can no longer arrange anymore. Does that make sense? The next formula is almost the exact same thing. Okay? So now we're gonna start saying NCR, C stands for combinations, all right? And then this formula, it turns out, is very closely related to the permutation formula. All you do is divide by r factorial. So you get n factorial over n minus r factorial times r factorial. All right, what do I mean by this? Why am I dividing by r factorial? Because now r is the number of things we're selecting for the group. Is that correct? So if I pick 6 people, right? No matter which 6 people I was picking previously, when we were doing this formula here, we were assuming you could reorder them. Is that right? But you can't. Does that make sense? So we have to divide out the r factorial many ways, because each time we were picking a group of 6 people, we were assuming you could order them 6, 5, 4, 3, 2, 1 ways. Does that make sense? Or 720 ways. Does that make sense? So for every 6 people we were picking before, there was 720 ways we can line them up. And there was another group of 6 people. There was 720 ways you can line them up. Does that make sense? We were counting 720 times too many before, as compared to the groups. Does that make sense? You understand what I'm saying there? If there's 6 factorial ways to order 6 people, we need to divide those ways out because we're no longer able to do that. Does that make sense? You understand?
I'll get there.
This stuff is honestly just practice. All right, so. Because there's only 2 formulas, you just have to know when to use each one. All right, so all that matters is that the previous case we were talking about, the order matters. When you're arranging things, the order matters, right? When you're just grouping them, the order doesn't matter. Does that make sense? So NCR is the number of groups taken R at a time from n distinguishable items, which is bigger, NCR or NPR, for the same values of n and r. that would be NCR. Right? They could be equal. But if they're not equal, NCR, oh, I'm sorry, I'm saying it backwards. NPR is bigger, I apologize, all right? They could be equal to each other, but NPR, the number of arrangements is more. We said that a few times, is that right? So I wrote here arrangements plus usually, all right? Why do I say usually? Because it could just be one way to do both of them. Does that make sense? Does that make sense? Like if I say you have one person, how many groups of one could you pick? Or how many arrangements of one could you pick? Well, there's only one person. All right?
What? I thought we were going doing geometry.
Not today. I don't know why you thought that. The so NCR is NPR divided by R factorial. So NPR is just N factorial divided by N minus R factorial, right? And then we're dividing that by R factorial. Because you are no longer arranging the R items within each group being selected, they must be divided out. So here's an example just to show you. So ABC, if I have 3 letters, how many 3-letter words could we construct using each of these letters only once? 3 times 2 times 1, or 6 different arrangements. Does that make sense? But all of these arrangements are the same group. Does that make sense? Right, because if someone sits here and they're like, oh, let's put A, B, and C in the group. And then you're like, no, don't do that, don't do that, don't do that. Let's put C, B, and A in the group. I'd be like, all right, bro, I got you. You know, it doesn't, it's the same thing, is that right? Okay, so the order in which the person's added to the group doesn't make any difference. The order, the way the person's put in the arrangement makes a difference, is that right? Question with this? So far? All right, so let's just calculate this one group thing here. So permutations, 3 times 2 times 1, we already saw that before. What if I said we have 3 people and we want to choose groups of 3? Okay. Well, there's going to be one way to do it. We just saw that 1. Is that correct? I mean, you have 3 people and we're going to make a group out of 3. You got to pick all of them. Is that right? So then the formula is this. You do this 3, you put it on the top. You do this one minus this one, just like we were doing before. Put it on the bottom. Does that make sense? Then you take this thing over here and you write on the bottom also. Okay? 0 factorial is the number of ways to arrange 0 things. There's one way to do that. You just don't do anything. So this part's 1. These 2 cancel here. We get 1. Does that make sense? That make sense? Yeah.
But like for like the group work, like the combinations, like if you have like 60 people, and they want groups of like 2, then there's only 30 groups, right? Because they can only be, you can't like put the same, right?
30 times 59 groups.
I thought groups.
So you have 30, what, 1800 minus 30, you have like 1770.
Okay.
Because the problem is think of it this way. All right. Well, because like you can think about this easily based on the stuff we talked about previously. You got 60 people.
Yeah.
Great. How many choices do you have for the first person in the group? 60. How many choices do you have for the second person in the group? 59. The only problem is that if I do 60 times 59, I'm counting too much stuff. Because then I'm saying that you and him is one group, and then him and you is another group. So I gotta divide by 2. So it's 60 times 59 divided by 2. And that's the same thing as saying 60 choose 2. Because 60 choose 2 is 60 factorial over 58 factorial times 2 factorial. 60 factorial is 60 times 59 times 58 factorial. 58 factorial, 2 times 1. Same thing I just said. 60 times 59 divided by 2.
1,770.
1,770.
Yeah.
Does that make sense? You understand? Sorry?
Absolutely. So
You gotta do your homework, or you guys watch the video from last time.
Question.
So the, yeah,
I've been trying to do the homework, and for every single homework, I need a password for every single one.
say again, the what?
I need a password to do the homework.
Password to do the homework? No, for the test you need a password.
Yeah, that's.
Oh wait, no, you already need a password for the test, I took that off. I don't know what you're talking about,
Yeah, look.
you just show me afterwards, you can't do it right now, just show me again. Alright, so evaluate, but you show me again, alright? Evaluate 13C4. How would I evaluate this? Also, what does it mean? What does 13C4 mean?
And make a combination of 4 out of 13.
That's correct. How many combinations of size 4 can we pick out of 13 distinguishable items? Or how many groups of size 4 can we pick out of 13 items? All right? It was a group, that's what that's what it means, right? But you're correct. Right? So so what is, how do I calculate this?
13 times 12 times 13 times
13 times 12 times 11 times 10 times 9 is 8 times 7 times 6. But first write it out this way. What do we have to write?
13 factorial,
Over
9 times.
9 factorial,
9 factorial times 13.
4 factorial.
4.
Okay? So this one goes on the top, this one minus this one goes on the bottom, and then this also goes on the bottom. Does that make sense? All right, how do I calculate this now? What's all gonna cancel?
factorial.
You go down 13, 12.
13, 12, I gotta go all the way down, right? So this is 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. What do I write at the bottom?
Right now.
9 times what?
4,
Nope.
8, 5 times 8.
9 factorial means 9 times 8 times 7 times 6 times 5 times 4, whatever. That's the number of ways to arrange 9 items. Is that right? What's 4 factorial? So now what? What do you do now? Come on. Simplify how?
You have 4, 3, 2, 1.
Well, I'd say we should do the 9s. Isn't that right? There's no way that's not easy. Does that make sense? Does that make sense?
That's
No.
the fastest way to do it.
Mm-hmm. 4, 3, 2, 1. I mean, you think it's not fast? You should be able to do that in your head, honestly. Does that make sense? That part. Because all you do is say it's 9 factorials on the bottom, so all I have to do is go to 10 on the top. Because the 9 is going to cancel, everything from 9 and below cancels. Then the 2 goes into the 10 5 times, and then this is actually pretty easy. Because now all you have to do is just do 13 times 11 times 5. 13 times 11 is 143, 143 times 5. Does that make sense? You understand? So this is what, 15, 21 carried to 715 or something, is that right?
How'd you get rid of the 12?
4 and 3 goes into 12. You just keep canceling stuff, does that make sense? Question with this? How would you do 29C16? This one I'd probably do with a calculator, honestly, this is a stupid question. 29 factorial over, this is 13 factorial, 16 factorial. So this would be 29 times 28 times 27 times 26 times 25 times 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17. Then it would be multiplied times 16 factorial, but the 16 factorial is just going to cancel. Does that make sense? Then all we do here And this is another way that, like, if you've done this a couple of times and you've tried to write it out at all, you would see that this is another way you can think about the formula, which is actually, believe it or not, a little bit simpler in the first way. Because all you do is you just write down, this is 29, choose 16, right? How do you do permutation? You write 29, 28, blah, 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 16 numbers. Does that make sense? Right? The only thing is we're not allowed to order these things within the group of 16 anymore, or within the group of 13 anymore, excuse me, there's 13 values we're selecting here, I'm sorry. Does that make sense? 29, C, 16 means. Well, let's use 16 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. $29 minus 16 is 13. Yes, 16 is right. Okay, that's fine. So then it should be 29. Yeah. One second. I'm getting dumb for a second. 10C7 means 10 times 9 times, this is 10 factorial. Oh, I'm reading it wrong, that's why. All right, I should have done this question first. So 10C3, all right? This is the number of ways to select groups of 3 from 10. Is that correct? Another way to write this out is to start saying that you do 10 times 9 times 8. Because that's how you would do the permutation. Does that make sense? Does that make sense? Right? Then, because there's 3 slots, is that right? Then you need to, all you just do is you just say, if I'm going to pick size 3 things, then I can no longer order the size 3 things. So I divide by 3 times 3 times 1. All right. So the previous formula we were just doing 29C16. Another way we can see this is 29 times 28 times 27 times 26 times 25 times 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16 times, what is this? 15 times 14 all over 16 times 15 times all the way down till 1. Does that make sense? All right. I started actually just canceling and trying to solve it already the other way. That's the reason why it looks slightly different. Okay. The 16, 15, and 14 would cancel here. Does that make sense?
Yeah.
All right. But the bottom line is, whatever way you want to do on your calculator, it's fine. This I would just do on the calculator. There is a button for the combinations on your calculator, though. It's in the math PRV section. It's on the left side of the calculator, right? Like it's like the 3rd or 4th button from the top left, which I think. All right.
I got 67.
Probably.
Wow.
You always multiply out. Same thing. You just don't want to try.
For that one, that's too big. The one on top. 13, 14.
I wouldn't do it either. I said that before. But could you do it? Sure you could. See, it's just, I don't want to, but you definitely could. All right. So the, that's why I said it's a stupid question. So find the number of combinations, subsets of 8 things taken 3 at a time. This one's more reasonable now. Okay. So 8 things taken 3 at a time. How would we calculate this? What would you say? So I'll jump at once.
Okay. And like,
Yep.
7, 6, 5.
That's true, but so you could actually just stop at 3 though. Is that right? 3 things. Does that make sense? So you could just write this as 8, 7, 6 over 3, 2, 1. Now, I'm just showing you now. Once you do a couple of these, you start seeing like now I could do this in my head. Because it's just like 3 and 2 cancels with this and I get 56. Does that make sense? All right. Now 8C3, we could of course just use the formula also. There's nothing wrong with that. I'm just trying to show people, you know, what it means also. Okay. So then this is going to be 8 times 7 times 6. Then there would be like a 5 factorial here, I guess. We'll leave that one there. then these two cancel, and now this gives you the same thing I just wrote. Does that make sense? Which again, it has to, if it doesn't, then I'm doing something wrong. Does that make sense?
Yeah.
All right. You get what I mean though? So like, what I'm trying to say with these things is that when I was in school, when I first learned this stuff, they weren't letting me use a calculator, right? And then they did start letting us use a calculator. And I found that the kids when they were in class were actually doing it better before they let us use the calculator. Surprisingly, all right? And then I was like, well, why? And the reason why, honestly, was because people just were trying to memorize too much, and they didn't understand what it meant at all. And then once they had the calculator, they were definitely just typing in the calculator, and then they really weren't thinking about it anymore. Does that make sense? All right. So anytime anything changed or got even a little bit harder, the people start getting them wrong.
They're making 29, C16, like, you have to figure out.
We'll put it like this. I used to know, okay, when I was in middle school. All the factorials up to 25. I used to know all the times tables, 25, 25, like what any of the numbers up to 25. Just because when they made you do the questions, it was just like, okay, well, I'm gonna remember now because so many times they made you do it, you know what I mean? And the same numbers pop up over and over and over again, so you start remembering them. At the beginning, I definitely didn't know anything about. Honestly, after a while, I started preferring doing it later. Because when I do it on the calculator, all I have to do is miss one number. And then I just don't know it's wrong. You know what I'm saying? You don't know. You need a way to check it somehow. And then the only way is this stuff a little bit. I still do some things on the calculator because like I don't want to multiply these big numbers and stuff like that. But if you don't do it at the beginning with the basic ones, I don't think the person understands, honestly. I don't understand how they can understand what it is. All right. So how many different choices does Marissa have in positioning the 10 houses if she decides to build 4 standard and 6 deluxe models? What the hell is this? Marissa is trying to build 10 homes on a block using 2 different models, standard and deluxe. How many different, so this is now trying to relate some of the stuff we're learning now, some of the stuff we did previously also. Okay. So this particular example is kind of important. How many different choices does Marissa have in positioning the 10 houses if she decides to build 4 standard and 6 deluxe models? But I'm going to do this 2 different ways. Okay. One way is I'm going to call the standards S and the deluxe is D. Does that make sense? And this should now remind you of stuff that we did last time. Because if it's effectively saying there's 4 S's and there's 6 D's. Is that right? And I have to see how many words I can make. Is that correct? Does that make sense? So then what's the answer? 10 factorial over 4 factorial, 6 factorial. Is that right? Does the S's repeat 4 times and the D's repeat 6 times? Is that right? That's what we did last time, repeated permutation. Is that right? Remember that, Mississippi? Same question. Does that make sense? You understand? You get why I'm saying that? You can think about it. You got houses, they're all lined up, right? There's 10 lots. S, S, D, S, D, 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 S, whatever. I don't know which way we're gonna put the houses, but effectively, we're not like the D houses aren't distinguishable from each other, right? The S houses aren't distinguishable from each other, the same model. Does that make sense? Does that make sense? So you can't reorder within those groups anymore. Is that right? So we have to divide out the number of ways we could usually order the S's. We got to divide out the number of ways we could usually order the D's. Does that make sense? You got me? Simone? Another way we could do this is we could say this is either 10C4 or we could say 10C6. Because 10C4 and 10C6 are the same thing. This is important for you if you don't understand this. So like NCR is equal to N factorial over N minus R factorial times R factorial, right? But if I do NC N minus R, N minus R, n and c minus r is n factorial over n minus r is just r. And then there would be,
Exclamation mark is minus a factorial, right?
well, the point of what I'm trying to say here is that, if I should do it with a number. 10c6 is 10 factorial over 10 minus 6 is 4, 6 is 6. If I do 10c4, this is 10 factorial over this minus this is 6. This part is 4. These two stupid things are the exact same thing, they're just changing the order and the way we're dividing in the denominator. Is that correct? Now, again, this is. It's usually pretty easy to see how it works algebraically, honestly, okay? Like to realize these two things are the same, that's not too confusing. Does that make sense? Right? But then if I ask the question, why? Which this is the part that's actually more important to understand how to do the questions, all right? Why would they be the same? Why is it the same if I do, there's 10 people, we're gonna pick groups of 6, and there's 10 people, we're gonna pick groups of 4. Why are there the same number of ways that we could do this? No. Just changing positions doesn't even matter in this because we're talking about groups. All right,
Is it because it's the same, is it you have 10 there, so whether you have group of 4, group of 6, it's the same 10,
no,
no?
I mean. Sort of a little bit, but not really, all right? All right, so let's say I got 10 people, and I want to pick 6 people, and we go into the club. Don't laugh. You won't come with me anyway. So the 10, and we have 6 people, and we go take them out. All right. How many people get left over?
4.
So in other words, every single time I pick the 6 people that are going, I'm actually always picking 4 people who
Stay.
they're not going. Is that correct? That means I'm actually picking groups of 4 each time. Is that right? Yes, I'm picking groups of 6, but I'm actually excluding the 4 people, right? Which means I'm really selecting those 4. Is that correct? So whether I sit there and say to you, hey, let's pick the people who aren't going, or let's pick the people who are going. Once I pick the people who are going, well, everybody else ain't going. Is that correct? Once I pick all the people who aren't going, well, I guess everybody else is going. Does that make sense? So the thing is that if you have 10 people. Okay, and then I pick 4 to stay home, right? You already immediately told me the 6 that are going. Is that correct?
Right.
So if I tell you to select groups of 4, you're actually picking groups of 6 at the same time. Is that right? You're just not counting those people. Does that make sense? But you're still isolating them. Is that correct? You understand? So these two have to be the same thing. Every time I pick a group of 4, I'm picking a group of 6. Is that right? You know what I'm saying here?
Yeah.
So why is this the same thing as this question? All right, so again, there's 10 lots, right? I need to pick 4 of the lots. And I'm gonna put standard houses on those lots. Is that correct? So which group of 4 do I pick, right? 10C4. Does that make sense? Or I could say there's 10 lots and I want to pick 6 of those lots to be the deluxe homes. I need to pick 6 lots then. Is that correct? So 10C4 and 10C6, they're the same thing, all right? All right, what number is this? What is 10C4 or 10C6? What's the number now? What's the number equal to?
I got two.
What'd you say? So this is 10, 9, 8, 7, right? 4, 3, 2, 1. 4 and 2 cancels here, 3 cancels here, 2 10 is correct. 3 times 7 is 21. Does that make sense?
you do it for 6, right? Or would it be the same number?
Same exact number,
Okay.
so we don't even need to do it. You understand? Does it make sense, guys?
That way it's like a lot.
Same,
But it's easier to do, when it's
same,
quicker.
quicker is correct. But in other words, it's the same thing. 10 factorial over, this minus this is 6 factorial, this you're right here is 4. So then I know like the 6, 5, 4, 3, 2, 1 is gonna cancel. So then you would get 10, 9, 8, 7, right? 6, 5, 4, 3, 2, 1 cancels, then you have 4, 3, 2, 1 left over. Same thing. Does that make sense? Question?
Still like sets, like that one.
This is
or like-
combinations, or this is counting. Sets was the first unit. If Marissa builds 5 deluxe and 5 standard, how many different positionings can she use? Then C5 is correct. So then that would be 10, 9, 8, 7, 6, because there's 5 of them, right? And then 5, 4, 3, 2, 1. 5 and 2 is 10. 4 goes into 8 twice. 3 goes into 9 3 times. 6 times 6 is 36 times 7 is 42. Carry the 4. 3 times 7 is 21. Is 252. Does that make sense? Question?
It's like, your brain works so fast.
For real. You can't catch up.
Yeah, but that's just because I've done this shit for 40 years. What the hell is it? You know what I'm saying?
Right.
Like, I always hate it when people sit there and they look at somebody who does math and they're like, oh my God, that person is so smart. I'm like, yeah, but so what? How many different things you can do that I probably can't do for shit, you know what I'm saying? And the point I'm trying to make is that, like, you go watch someone playing basketball and they just start blowing it out, right? And you're like, oh my God, this guy is good at basketball, right? So people are usually like, you know, I could probably do that. If I played more, I could probably do it. You know what I'm saying?
And practice.
Right, if I play more, practice and whatever, and you know, honestly, if you don't think like that, I just think you haven't tried, because I'm telling you, I never used to be able to dunk, and then one time when I was like,
You can dunk?
not anymore, I
Oh,
can't shit
okay.
now,
Damn.
but but when I started like, working out a lot, when I was like 18, I think I was like 19 years old, one day I go into the gym, and all of a sudden,
Yeah.
I dunked, and I was like, oh, wow,
Okay.
it was, they were telling the truth, all my coaches, when I was younger, that if you work out, it's actually gonna work.
Yeah.
It took me a freaking year and a half straight of working out all the time, but you know, it did work.
Have you,
But but yeah,
have you heard of the strength shoes? The strength shoes?
yes,
I have heard.
those are actually, because those things are,
Well, plyometrics.
but there were originally, there were these boots that they make for, when you do squats or whatever, you know, like you sit there and you have to
Yeah.
do squats or whatever,
Uh-huh.
like this is boots that's made so that it keeps the person straight more often. Because the problem is you put too much weight on, what ends up happening when you go like this, like your knees start moving and stuff like that, and you just, if they're not straight,
Mhm.
it causes a lot of problems for your knees and stuff like that. So then, and your ankle, honestly. So they made these boots that you use for this stuff, and then they made it for this too. But anyway, my point just is that you'd be surprised what you could do if you spend a little bit of time doing it each day. You'd be really surprised, okay? Because honestly, we're all just lazy and we just don't want to do it. You know what I mean? But if you sat there and you spend an hour a day doing, I don't know what, you pick it. You don't know anything about it. It doesn't matter what it is. You start doing it for an hour a day. You tell me do it for a year. You probably don't even got to do it for a year, but you do it for a year. I don't know. I'm telling you, you'd be better than me, whatever it is by then. And I've been doing it for 40 years, this crap, but, well, I'm exaggerating, but still.
So
I'm
basically,
gonna go with the 40.
so basically what you telling me is if I train really, really hard
For
for
anything,
a year,
for anything.
I can beat you in basketball. But
Well, you should go beat me in basketball right now. I can't
yeah,
shit right now.
yeah.
But
Yeah.
but put it like this, if I train for a year, I'll kick your ass in basketball.
Okay,
So
alright,
the,
now we're dreaming,
the-
now we're dreaming, now we're really dreaming.
electronics store, received a shipment of 20 graphing calculators, including 6 that are defective. 4 of the calculators are to be selected from a central local high school. How many of these selections will contain no defective calculators? As a shipment of 20 graphing calculators, okay. 6 that are defective. So that means 14
Oh,
are working, is that right?
oh,
They're gonna pick 4 of them and send them to the high school,
14, no.
right?
14.
How many of these selections will contain no defective calculator? This is kind of a. Okay, so this is gonna confuse some people, but honestly, this one's just read it. Okay, so this one is not that hard, it's just very, very, very wordy, all right? So there's 6 defective and 14 not defective. It says how many of these selections will contain no defective calculators? Well, then I just got to select from just this group. Does that make sense? Yeah. So it's 14, choose 4. No, I don't want to do this in my head.
Man, oh my gosh, honestly, 11 more credits and I can graduate.
No, there's always more. I'm just telling you.
My mom told me, oh, after I graduate from BCC, oh, you going to FIU and you gonna get your bachelor's.
That's what I'm saying.
Oh
See,
my
you're not done
God.
yet. Not done yet. So the that's what I said when I was in school. Like after high school, I was like, oh, I did all this stuff. I did a good job. I'm gonna go to college. It's not gonna be that much, you know. I never went to class. I didn't do anything. All right, like you think you got bad grades or something? Wait till I show you my grades sometime. All right, but I didn't do anything. Okay,
Daniel,
sorry.
name Daniel mean nothing.
Yeah.
That's
And
great.
then I graduated still somehow. I don't know how I was there. Deserve it. And then
I feel,
then I went to master's degree.
you got a master's?
I got 2. So
You
then
Okay, you got a dual major.
I didn't do a dual major. I just did master's degrees afterwards. I had to do it later. But so I got a master's degree in engineering. The only reason why I got a master's degree in engineering was because I had such a bad undergraduate GPA that I was worried I wasn't going to get a job. But master's degree is only 1 year.
Master's degree is only 1 year? I thought master's
That's
was
how they
like
treat.
4 or 5.
That's how they trick you into getting it. Because after you do 4 years undergrad and someone turns around to you and you're like, yo, you want $30,000 extra a year for doing this stupid bullshit? You're like, yo, how long is it? They're like 1 year. You're like, yeah, I'll do it for 1 year. You know, so like so that's why I did that. Then I got a job and I was working in banking and all that stuff, and I realized I was like, you know some of this stuff. I was like, you can make more money. I was like, let's go get a job that's fancier.
Right.
But then it started asking for all these math degrees. I was like, I don't have a math degree. I was like, I have a master's degree in engineering. They're like, that's not good enough.
Wow,
I was like, oh,
wow,
I was like, great.
that's
I
great.
was like, I'm glad I got that. So then I went and got a master's degree. I was supposed to get a PhD in math, and I just quit. I didn't want to do it anymore. But you get what I'm saying here? This one?
But if you have master's, you can call yourself doctor. but you-
No.
You're a PhD, we call it doctor.
But honestly, even if I had a PhD, I wouldn't let people call me doctor. Because the thing is my dad, my whole family is a bunch of medical doctors. They're all,
When you're feeling
they're all Indian. So they're all doctors. And I was told by my dad not to become a doctor when I was like 18. I was always gonna be a doctor, medical doctor.
Right.
And then because he had a lot of problems when he was a doctor. He's an OBGYN. And he also practiced neurology. And he used to make like, I don't know, $450,000 a year, no joke. Like in the late 80s, early 90s, stuff like that. Like a lot of money, a lot of money. Okay. And then one day they were like, They were like, yeah, you have to see 3 times as many patients and you're only gonna make like about $250,000 a year.
Hmm.
And he's like, nope, I quit. I don't wanna do it. I'm not getting sued. I'm not gonna sit there and have this woman have her baby end up having a problem. And then remember this for the rest of my life and all this stuff like that. So he tried to deal with it, couldn't deal with it. People started leaving his practice and going all over the place and going to all these other places because it was cheaper elsewhere. And that was the end of that. Then he quit being a doctor. So then I was like, okay, well, you know, I still want to be a doctor. Everyone's want to be a doctor. So I was a kid, you're a doctor, you know, whatever. He's like, no, don't be a doctor.
Do what you love.
That's true.
Do what you love.
You're right. But I looked at the money and that was all I looked at. And I looked at how much time it was gonna take and stuff like that. And I got scared. I don't want to go to school that long. and stuff. Meanwhile, I ended up going to even more school. But the
Yeah, I see. That's exactly what my mom told me. After you get your.
No, I'm saying, like, you don't do
you
don't do what you want. You don't do what you want.
Yeah.
You're gonna do some bullshit you don't want to do. And then afterwards, you're gonna be like, oh shit, that's what I wanted to do before. I better do it now. Then you're like 35 with 7 kids. All right, so then all right. So in a race in which 9 automobiles are entered and there are no ties, in how many ways can the 3 first finishers come in? This one's not bad. Anybody help me with this one? Number 8.
Then start with 9C3, and then for the initial 9C3 to be 84 and 84.
Not 9C3.
Not 9C3?
No, see, they scammed you.
Oh,
Because the problem is now the order actually makes a difference. When they start saying first 3, wait, let me read this shit. In a race in which 9 automobiles are entered and no ties, in how many ways can the first 3 finishers come in? Alright, let's- Okay, I this is really, I don't like this question, but let's go with 9C3 or what you said. All right, the reason why I don't like this question is because when they say first 3 finishers come in, right? Saying 9C3 means 1, 2, 3, you guys got the top 3 places. But it's not saying which place you got. You understand what I'm saying? If they start mentioning which place you actually got, then it's 9P3. But given the wording of this question, since they honestly, this question is poorly worded. It's hard to say. Because when you start saying in how many ways can the first 3 finishers come in, I could either interpret that as saying the first 3 finishers, how many different ways are there groups of 3 for them to come in the first 3 places, right? Or I could say that it says the first 3 finishers come in, right? So that could mean who gets first, who gets second, who gets third. Does that make sense? So honestly, I wouldn't ask this question because of the wording. Does that make sense? Because I feel like people can interpret it both ways. All right, I had no idea what the writer intended for this.
How can we switch it, right?
So it'll be clear. In a race in which 9 automobiles are entered and there are no ties, how many ways? Can 3 people place? Does that make sense? If I say how many ways can 3 people place? Top 3, right? Then 9C3 is definitely correct. Does that make sense? If I say how many ways can the top 3 finishers come in, I would say 9P3. Because then if you, me, and her come in, right? And you come first, she comes second, I come third. Or if I come first, she comes second, you come third. I would say there's 2 different ways 3 finishers come in. First 3 finishers. Does that make sense? So, anyway, my point is like, this is now getting into like too much semantics. It should be more clear than that. Does that make sense? Yeah.
I forgot I'm supposed to give you, I probably have to call my mom after the class because I need to give you a form. I need to give you something.
No problem. Using a standard 52 card deck, how many 8 card hands would consist of the following? All clubs. So they write the deck here for us. So it's 52 cards. I'm going to pick 8 cards, and I want to say how many ways we can get all clubs.
1, 2, 3, 4. 4 times 2, 3.
No, you got to think about permutation and combination. What am I saying?
Wouldn't it be like 13 13 out of 52, like 26 out of 52, like
Mhm.
or no.
Definitely not 26.
All red cards, and then that'd be
No, he said close.
yeah. Then,
Oh, that, yeah, no, 13 out of 52 would just be saying pick one red card, one club. So in this first one here, how many things are we picking? Clubs are the first ones here.
13.
then the flowers.
We're picking 8 cards, right? You understand? How many could we select from? 13. Choose 8, because if we say we get 8 card hands. The order in which I get the cards in the hand doesn't make any difference.
Mhm.
It's still the same hand of cards. Does that make sense?
Mhm.
You understand why I'm saying 13 choose 8?
Okay.
There's 13 cards here. We need to pick groups of 8. Is that right? You understand? So this is the same thing as 13, 12, 11, 10, 9, over, 5, 4, 3, 2, 1. 4 and 3 is 12, 5 and 2 is 10. Or whatever this is. 13 times 99. 1300 minus 13 is 1287. Does that make sense? But it says all red cards now. How would you do that? Should be able to tell me that. 26. Choose what though? That's correct. Does that make sense? You have 26 reds now to pick from. Is that right? Does that make sense, guys? What about the next one? This is the one question every single person in here should be able to get correct. Without me teaching any single thing. This is just a reading question. There ain't no math.
Is it the same as 8? Is it the same answer as 8?
Read the question.
Oh, all the chance.
All tracks. And then we'll call it out. Fair enough. And then we'll switch it.
It would be really hard to make an 8-card hand of all jacks if there's only 4 jacks.
Alright.
You understand? You don't know which one jack is or what? This one, it says how many 8-card hands would consist of the following? All jacks. What?
No.
Maybe if they said all of the jacks.
Mm.
Let's do that, because I don't want to say this stupid thing. All right. Containing all of the jacks. Now this is now a bit harder, okay? But at least it's a better question. I do think it'll teach you still how to do this, okay? So, all the jacks, right? Well, we gotta pick all the jacks then, is that correct? How many ways to do that? Well, there would be 4 ways to pick all the jacks. There's 4 jacks, I'm gonna choose 4. Is that correct? That 4C4 is 1. Because how many ways are there to pick groups of 4 jacks and pick all 4 of them? 1, you pick all of them. Is that right? All right, 4C4. Now we need to select still 4 more cards. Is that correct? But they can't be jacks. Does that make sense? I mean, they can't be jacks anyway. There are no more jacks left. But let's say what other types we could pick. Is that correct? There's going to be something C4. What's the something? Very good. 48. Perfect. Does that make sense? Do you understand? There's one way to pick all the jacks, right? But then you would still have 4 slots or cards or places left over, but then there were 48 different things you could choose for those. Does that make sense?
Yeah.
With 48 C4. Does that make sense? Question?
94,000.
Yeah, it should be a lot. This game that they're referring to here is this game called like Bridge or something. I don't know how to play this game, but all I know is people that like math love this game. Because there's too many combinations. So only if you know math can you play it well. Does that make sense what I'm saying? The hands are too big. There's like 13 card hands and stuff like that or whatever. So you get a lot of different possibilities or something. There was this math teacher I used to know. He killed himself because the turns out a lot of these people killed themselves because. So remember we learned that all that logic stuff at the beginning of class? Right? Well, logic is logical. There's one way things happen and stuff like that. It's either true or false, like that's it, right? But life don't always work out that way. And life isn't exactly always fair, right?
Right.
So the thing is that some of these people can't deal with some of the ways that they have to interpret what happens actually in life. And then they actually can't handle it and they go and they kill themselves. But anyway, the only reason why I just thought of this is there was this guy who was absolutely like amazing at that game Bridge. And he was into this logic stuff. And everybody always used to say that people that do logic are very close to being crazy. But it's true.
I mean, they say Einstein was crazy.
No, people say it. People say Einstein was a lot of things, but not that one. The number of ways certain condition can be satisfied is the number of total possible results minus the number of ways the condition could not be satisfied. Shorthand, this would be this: good equals total minus bad. Or the number of ways A happens is the number of ways in the universal set minus the number of ways that A does not happen. What they want to tell you here is they want you to start thinking about counting things, but using what you're not supposed to get to figure out the answer, okay? Because sometimes counting the regular direct way is actually harder, all right? So picking card from standard 52 jacks, how many ways can you get something other than a jack? So this is actually kind of easy. We would just say 48, but how am I getting the 48? 52 minus the 4 jacks, is that correct? Does that make sense? When tossing 7 coins, and how many ways can you get at least 1 head? All right, so this is the standard type of question for this thing.
How can you even determine that? So that's like all of the.
You can definitely determine it. What the hell? Muy extraño today. I got this program I installed on the computer that takes me through the screenshots or whatever, and somehow I never shut it off. It's not on. All right, and how many ways can you get at least 1 head? All right, so the number of ways to get at least 1 head in 7 flips, right? Now, like this would be annoying. This would be the number of ways that we could get 1 head or 2 heads or 3 heads or all the way up until 10 heads. This is really 9 different problems. I don't want to do those. Does that make sense? I don't want to go do 9 different questions, or excuse me, 10 questions. I'm sorry.
7 coins.
Sorry?
There's only 7 coins.
Oh, I'm sorry.
Oh, my God.
I don't know where the hell I got 10. 1, 2, 3, 4, 5, 6, 7. Sorry, any other class they asked 10. I just forgot the question. So then anyway, 7 though, you can, same thing really, does that make sense? Sorry, but there's 7 different questions we would have to do here, okay? Now, you know what? Let's do them so that you realize you don't want to do this shit. All right, so let's do 1 head, 2 heads, 3 heads, 4 heads, 5 heads, 6 heads. It's supposed to be 6, 7 heads. Okay, 7 coin flips. You have to get the answer to all of these and then add them all up, and then it should give us the total. Does that make sense? All right, 1 heads. 1 heads means how many tails?
1.
6. 7
Okay.
coin flips, right?
It's 7.
You get 1 head, you got 6 coin, you got 6 tails. Is that right?
Okay.
So then, in other words, this would be like,
Oh, I got it.
this is like H, tails, 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 right? But the H doesn't have to happen in the first one. Does that make sense? You understand?
I get it now.
You understand? So this is the same thing as saying 7 factorial over 1 factorial, 6 factorial. Is that right? Does that make sense? You can think of this 2 ways, either as the letters, or you can think of it as you need to pick groups of 6 for the tails. Does that make sense? There's 7 ways to do that.
5.
This one is 7 factorial over 2 factorial, 5 factorial.
Right.
Does that make sense?
Right.
This is the same thing as 7C1. This is the same thing as 7C2. 7C2 is the same thing as what? 7 times 6 over 2 times 1. We get 21. Does that make sense? 3. This is 7C3. 7 factorial over 4 factorial, 3 factorial. This is 7, 6, 5 over 3, 2, 1. 35. Does that make sense? You understand? All right, 7C4 is also 35. 7C5 is the same as 7C2. It's 21. 7C6 is 7. 7C7 is 1. Does that make sense?
Wait, you got confusing on the last part.
Which one?
Repeat the last part.
Where? Here?
The, after
Here?
21, after 21, you lost me.
That's a 2 and 1. 7C3.
Yeah,
Repeat this part.
yeah.
So 7C3 means you're picking 3 heads out of the 7, right? So that's 7 factorial over 7 minus 4. 7 minus 3 is 4 factorial, right? The 3 factorial over there. This is 7 times 6 times 5 times 4 times 3 times 2 times 1. This is 4 times 3 times 2 times 1. So the 4, 3, 2, and 1 cancel. You just get 7, 6, and 5.
11 more credits, man. Oh my God. 11 more credits.
So then this, nah, bro.
Nah, don't give me that.
76,
Don't give me that.
71, excuse me. You still got at least 60 for your bachelor's. All right, so then.
Damn.
and
Damn, that means
then you want to do masters? 36.
no, hell no, hell no. I'm
36.
getting a back.
So then
I'm
the,
getting a bachelor's, I'm getting a bachelor's.
all right, but anyway, we have to add all these up. Does that make sense? How much was it? No,
No.
that doesn't have to 120.
What, 21?
Yeah,
That's a defense.
should be 127. 1, 8, 9, 10, 27, yeah. So add it up. So add it up here.
Yeah.
So 7 plus 21 plus 35 plus 35 plus 21 plus 7 plus. Okay, that would do it. Well, someone's still on. 7, 21, oh, because I didn't write the right number here.
35.
See what I'm talking about? I want to use these damn calculators, so we can make.
35 plus
All right, so then the 127, right? All right, so that was the hard way. Hopefully you understand what I did there, but that was the hard way. All right, so the idea is that what you could do is you just count the total number of ways and subtract the ways that we don't want. So what does that mean? At least one heads is like X is greater than or equal to 1. Is that correct? What's the complement of that, or what's not that? If I say you have at least one heads, what's the complement of that? No heads. Is that right? So if I count the total number of ways, the total number of ways is actually pretty easy. There's 7 coin flips. 1, 2, 3, 4, 5, 6, 7. There's 2 ways to do each of these things. They could either be heads or tails each time. Is that right? So it's 2 to the power of 7, which is 128. That was the only reason why I could tell you what the answer was, because I was like, oh, I know 2 is but 7 is 128. So I know it's gonna be 2 to 7 minus 1. Because the ways that we don't want are now the ways that you would get no heads. The complement of getting at least one heads is no heads. Is that correct? How many ways would there be to get no heads? Well, that means they all tails. Is that right? One way.
But why would I get no head?
I see you.
Yeah,
I see
you
you.
know I did
So
that.
this one, you got it here? You get what I'm saying? But the whole point of this is to show you that maybe it's easier sometimes to count the things you shouldn't be doing and then just remove from the total than sitting here and doing these 9 different questions or whatever, or excuse me, 7 different questions. I only had to do 1. Does that make sense? How many ways can she get at least one head? So all we need to do is 2 to the 7th minus 1, we get 127. Gina's collection of 10 albums includes 1 rock album. Gina will choose 3 of her albums to play on a road trip. How many different sets of 3 albums could she choose? Okay, so this should be 1 here, not on. Gina will choose 3 of her albums to play on a road trip. All right, so the fact that they mentioned that it includes 1 rock album doesn't matter. It's an album. Does that make sense?
Right.
So how many sets of 3? I mean, does that sound like groups or arrangements? Does the order matter or does the order not matter? Doesn't matter. She's just saying which 3 CDs is she bringing, which 3 albums she bringing or whatever. So this is gonna be 10 C3. Does that make sense?
Can't see through.
Kind of funny though. You don't bring rock albums anymore.
This is wrong. Everything get jiggy.
No, it's just like, do you guys even have like album? You like do you even call,
No.
do you even call things albums? and stuff?
No, some
You
people,
do?
yeah. Some people like real like
You
music
call things
heads.
albums?
Yeah,
Okay, good.
yeah.
No, it's like the kids that I teach in the high school and stuff like,
Digital, there's everything digital.
yeah, they don't, like you say album, they're like, what are you
What
talking about?
was
So
that?
then they just call it song. They don't even call it that,
A mixtape,
because everything is Spotify now.
yeah,
You know
with
what I'm saying?
SoundCloud.
They don't listen to it in terms of the album as often. They listen to it just in terms of the song.
Yeah.
And then they just get suggested a new song, so then they never think of the album and how they're all, what we put together then often. Unless someone's really obsessed with particular artists.
Right.
Like, one way to do that is like 10, 9, 8, 3, 2, 1.
Yes, sir. Very good. Which is 120, all right? How many of these, sometimes the number's too big though, you wanna do it on a calculator, you make sure you're able to do it on there also, right? How many of these sets would include the rock album? Okay, so if I have to pick the rock album, right? Then the other 2 I can switch, is that correct?
Right.
But if I have to pick the rock album, I kind of can't do anything, so I just write a 1 there. And then the other 2 here, it would be what, 9C2, does that make sense? Question, sorry?
So with the, because the side question, would they want to do a process like at the test and everything? Would they, ask for approximation, or would they usually ask to round off?
No, there's no decimals or anything in this stuff. Because it's always like, how many ways can you do it? You know what I mean? So either it's like 5 ways or 6 ways. There's no like 5.7 ways or something like that. So you know, if you get something like that, it means you type something wrong in the calculator. All right? This is a good question though. How many of them would not include the rock album? All right, so this is, how would you do this?
Just add another one. Put 11, no.
How many you just subtract?
Yeah, we're.
This is
120 less 36. Is that correct? If there's 120 ways for them to pick the albums, and there's 36 ways to pick the rock albums, well, 120 minus 36 have to be the way to pick the not rock albums. Or not, excuse me, to pick the 3 albums, but not pick the rock album. Does that make sense?
84, yeah, it's 84.
Question with this? You understand? Does it make sense, guys? Oh, look at this. We've seen this formula before. Like twice already, okay?
You know what that?
Sorry?
This should look-
No, I didn't write it. But you know why she's saying that?
Yeah, maybe it is.
Because she's sort of related to the stuff we did before, so, and we're gonna need this for both these 2 chapters, this one and the one on probability. If you roll 2 fair dice, how many ways can you obtain a sum of at least 3? Oh, come on. Alright, so. We have already done this. I don't know if you remember. But we wrote out. We wrote out this product table thing, right? Which was like all the ways. You can do one of the dice and then all the possibilities for the other die, right?
Only one way to.
No, it said at least 3.
Like, it's all-
There's 2 ways also to get 3. You get 2 on the first die or 2 on the second die. You get 2 and 1 or 1 and 2. If one's a red die and one's a blue die, right? And you roll the dice. Those are 2 different ways. Does that make sense? So I could use this table to write out all the sums. 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 1 is 4, 4 plus 1 is 5, 6, 7, 3, 4, 5, 6, 7. Does that make sense? 4, 5, 6, 7, 8, 5, 6, 7, 8, 9, 6, 7, 8, 9, 10, 7, 8, 9, 10, 11, 8, 9, 10, 11, 12, right? Now, if we want to do what they said at least 3, right? That's really all but that one. Is that correct? So how many ways are there?
But it's saying that you use all but 2,
How many ways can you get at least 3?
that would 2.
2 dice. You roll 2 dice. How many ways can you get a sum of 3 at least? Nope. I just wrote out every single case. What's the answer? You roll 2 dice. You tell me there's only 3 ways you can get at least a 3? When you add the 2 dice up?
6 times 6 different ways. On dice,
I wrote them all out here. How many of those numbers are at least 3?
oh, at least 3.
Yeah. 35 is correct. How'd you get 35?
Minus 1.
And that's exactly what they want you to do. Because what you're supposed to do is not really write all this stuff out. You're supposed to remember this from before. Does that make sense? There's 6 choices for this one, and 6 choices for this one. So the total number of ways minus the, as she said before, the bad ways or whatever, right? Which would mean really less than 3 as a sum. Is that correct?
Yeah.
Does that make sense?
Mhm.
So the total number of ways. You have 6 choices for the first one, 6 choices for the second one. The number of ways you can get less than 3 really just means 2. There's only one way to do that. So you get 36 minus 1 and 35. Does that make sense? Does that make sense? Question? If a single card is drawn from a standard 52 card deck, in how many ways can it either be a spade or a heart? So like, they gave you this formula here, I'm gonna use it, but like, I don't think I would really use it here. I mean, how many spades are there? How many hearts are there? What's the answer? Yep. You can't draw both a spade and a heart at the same time, is that correct?
Right.
So if I was gonna use this, I have no idea why they wrote this here. You didn't need it for any of this stuff. But the number of ways that we can get a heart or a spade has to equal to the number of ways that we get a heart plus the number of ways that we can get a spade minus the number of ways that we can get both a heart and a spade. Number of ways you can get a heart, 13. Number of ways you can get a spade, 13. Number of ways you can get a heart and a spade in one card, 0. You get 26. Does that make sense? Oh, there's more questions. Okay, that's why she was putting that formula there. All right, so if a single card is drawn from a 52 card deck, in how many ways can it either be a club or a jack? All right, this time they do start overlapping. Is that correct? Now, the way I would do this is there's two different ways. I would say you can count the clubs and then count the jacks you didn't already count. Does that make sense? How many more jacks do we have? 3 is correct. Good. 16. Does that make sense? Or you could count the clubs, you can count the jacks, and then subtract the number of things that are both clubs and jacks. Does that make sense? Did you get the same answer? Do you understand what I'm doing there? Any question with this? Anybody? If a set has 14 elements, how many of its subsets have at least 2 elements? What a dick. If a set has 14 elements, how many of its subsets have at least 2 elements? Well, first you have to remember how many subsets there are. The formula for subsets is 2 to the power of n, or this 2 to the power of 14 in this case, which is a fairly big number, all right? I think it's like 16 times 1024 or something like that. Is that right?
16, 3.
Yeah, that's right. All right, so then, so has it given 14 elements? How many of its subsets have at least 2 elements? So this is the number of subsets. Right? Does that make sense? Now we have to subtract from here the number of subsets with 1 element and the number of subsets with 0 elements. Does that make sense? How many subsets have 0 elements? 1 empty set. Does that make sense? How many subsets have 1 element?
2. No.
Read the question.
Two.
Pretty sure. 14, obviously. If you have 14 elements and you're gonna pick 1 element subsets, there's 14 of them you could pick. Is that correct? There's 14 people and you want to pick 1 person at a time. How many ways do you do it? 14. Is that right? So then this is gonna be 14 here. So in other words, that's the answer, whatever this is. 2 to 14 minus 15. Does that make sense? Does that make sense? The table to the right categorizes 20 senators for political party and gender. 1 member is chosen at random. How many ways can the chosen person be a man or a Republican? All right, when they do this, like, if you can't get this one, when they give you the table here, you're confusing the shit out of yourself. Because I'm confident you could actually do this question before you started this class. All right? It's the only thing that confuses people with these sometimes is that we've gone through all this stuff already. Does that make sense? All right. So we'll do it a few ways, but let's just see if we can do it. Like, what would the simplest way to do this? To do how many ways can the person be a man or Republican? Given this table, what would you say?
It's divided by 12, no? Oh,
What would you say the answer is? And this one legitimately is just reading.
well,
You don't need formulas, nothing. You're gonna choose one of these people out of this thing, right? And we want them to be a man or a Republican. Does that make sense? How many ways? What did you say? 19 is correct. How'd you get 19?
I added the men and then the Republican woman.
That's correct. So like, or that's one way to do it. So like, if they say count how many ways, so you're gonna pick the one person, right? So like, well, how many ways, which people could that person be, right? So, well, they could be these men here, is that correct? And then they could be Republican also. Well, the only person I didn't pick over here who's Republican is that person. Is that right? Does that make sense? So then you would end up getting 6 plus 12 is 18 plus 1 is 19. Is that correct? Now, another way you can think about it is we could use the whole set stuff in that formula, but honestly, it'd be pretty stupid to do it this way. But so if I say the number of men or Republicans is going to equal to the number of men plus the number of Republicans minus the number of men who are Republicans. Is that correct? You understand? The number of men is 18, right? The number of Republicans is 13. The number of males and Republicans is 12. Is that correct?
Yeah.
So we get the 19. But I think it's much more straightforward just to say 6 plus 12 plus 1. Does that make sense? So that's why when I see the table, I think it actually makes it much more easier. Does that make sense? What I'm saying? And the only thing that's going to confuse you if you try to apply the formulas and then you don't really think about it. Does that make sense? The other reason why this is important is standardized tests almost always have something like this on the test. Some stupid table, you got to read the thing and then respond. When I see those questions, I'm like, yes, I'm going to get this right. I haven't gotten anything right so far, but I'm going to get this right. But then like, I feel like people think the other way though, sometimes. I think people sit here and they're like, oh no, it's going to be math. I'm not going to remember the formula. And then they start confusing themselves. All right. But these are the ones that are actually your best friends, in my opinion. All right. Any questions? Then I guess that is all. Have a good evening. Let me see your computer there, bud.
yeah.